swing is located close to the house. When the child swings, the closest they get to the house is 1 meter away, and the furthest is 3 meters. It takes 2 seconds to complete one full swing. Assume the child starts swinging from neutral position, okay? That's the average between, neutral would be straight up and down, so that would be the average between her high and her low. All right, determine sinusoidal equation. In your opinion, do we have enough info to do a sinusoidal? What do you think? We need, this is what we need, right? We need y equals a sine, it could be sine or cos, b, x minus c plus d. All right, as long as you're given either the max and the min or the average and the max, you can get, you've got your A and your D, right? I think we have enough info for A and D, don't you, Rahel? Yeah. And what we need for, C is kind of arbitrary. C is the one I'm going to leave, and C can be so many different values. C is actually it might be the hardest to understand initially, but it's the easiest to work with because you have many spots you could start C at. You also have the option of calling this sine or cos. That helps you with your C value too, right? So don't worry about C. As long as we're given the period or the time of one rotation or one sequence, you've got the period, right? So I think we have enough info, correct? So what do we have here? What we're going to do, I always like to draw a quick little picture because I think that helps. So I'm going to do, most of your applications are quadrant 1. So what do we have here? What are the units of measure? Meters and time, or meters and seconds. So this is going to be meters, this is seconds. So this means that this is time. And this is the closest, the furthest from the house. So this would be distance from the house, right? The question tells you exactly what you're tracking, right? Just look for your 2 units. Decide what axes they go on, and that can get you started. All right, I wasn't asked to graph this, so I'm just doing a real quick thumbnail sketch. So I'm not even pulling my ruler out. I'm just doing getting my numbers so I can get my equation going. So what do I need on the y-axis? I need a max and a min and a middle value. So my maximum value is 3. My minimum value is 1. Okay, do we have to do the math, or can you give me the middle value between 1 and 3? Must be 2, right? So that's my D value. Okay, so D is 2. What's A? 1. Was that you, Ibby? How did you get the 1? Yeah, so from here to here, or from here to here, or the formula that you use actually gives you, you take the 3 and the 1 and then, average them out to get your 2. So however you do your A, there's lots of ways to do your A. Okay, so we've got A and D. We've already got 2 parts of the equation. So now it says, assume the child starts swinging from the average position, the neutral position. She's halfway between, and that makes sense, right? Because when the child hops on the swing, they're kind of just sitting there, right, motionless, before she starts pumping. So that means she's going to start at the middle distance between the high and the low, right? Which would be 2. So she's going to start swinging right on the median line. Okay? And then she starts swinging, so you have to tell me how you swing. What do you usually do when you swing? Do you remember swinging as a little kid? What do you do first? You go back first, right? So you go further away first, don't you? Yes. On the graph, if I go further away, which am I going to go up or down? Up, right? So this graph is going to do something like this, agreed? She goes further away. That's usually what you do, right? You go like this with your feet, and then you let go and swing. Okay. What kind of function does that look like more like to you, a sine or a cos? I think sine. Okay. So we go up to 3, we hit our neutral position, and then we go all the way back to our neutral position after we go close to the house. Now the only thing I need, I've got all my A and my G, I just need those middle values, B and C. It says it takes 2 seconds to complete 1 full swing. Okay, so doesn't that mean 1 full cycle? This would be 2 seconds. Okay, 2 seconds. Okay. All you need is the distance or the time for 1 full rotation or 1 full swing or 1 full cycle of whatever you're tracking. You know that then you just carve up your, this would be a half, right? 0, a half, 1, 1 and a half, 2. Okay. I think we have all the pieces. I need to figure out what B is though. So B will equal 2 pi over 2. I guess I should have kind of highlighted this too and said that that 2 seconds represents the period, right? So the period is what's displayed on your horizontal. So this is the period. Okay, so B will equal pi, and I just have to decide on C. Like I said, I have many options for C. What do you want to go with for C? We called it a sine function. 0. Perfect. Putting it all together. So I have y equals 1, well I'll leave the 1 off, sine pi x, I don't need to do x minus 0, plus 2. And I just kept my variables x and y. Okay, how far away from the house will the child be in 9 seconds? Now this is what I said at the beginning. We're assuming something really big here. We're assuming the child keeps swinging at a constant rate the whole time, which isn't probably super realistic, because I don't know if you, I remember when I was swinging and as a kid, the harder you pumped, the higher you got, right? You tried to get super high sometimes, so you don't always, I don't think every kid pumps at the regular rate, but okay. See if you can figure out how far away she'll be in 9 seconds. Okay, what did you get? That's what I got. So y equals sine pi times 9, right? Now if you're doing this in your calculator, you might have to bracket those off because they're both part of the angle measure, right? Or sorry, both part of the argument. Plus 2. And I punched that into my calculator. I made sure I was in radian mode, because they gave me radians to work with, and I got 2, and it would be meters. Good. Okay, that's sort of how your trig functions will go. It's quite simplistic, but a trig model is, because it's so repetitive, right? The ones in the book, when I look at them now, and I should have looked a little more closely, they, I think, are assuming you're punching them these all into Desmos or the graphing calculator. It would have been easier without this denominator, right, of 12.4 and 365, so that's where they came. So I would suggest you leave these guys and Yeah, leave these guys out, and I'll give you another paper to work on, okay?